Hello everyone, I hope you all are doing well. So here I'm going to just go with the basics of model analysis, that is frequency analysis. Okay, we'll see what and all the basics we should know before getting into this particular model analysis in depth. So these are the things you could see the formulas and all. Okay, the frequency is equal to 1 divided by time period, that is frequency equal to c by lambda as well. Okay, so lambda is the wavelength in meters, frequency is 1 by t, in hertz it is measured, the t is the time period, that is duration in seconds. Formula is you can see t is equal to lambda by c, frequency is equal to c by lambda. Okay, so if you're going to link these things, so finally we're gonna get the frequency which is equal to c by lambda. Okay, c is the wave speed and lambda is the wavelength. Okay, yeah, so when it comes to this analysis, what exactly this is and why it is needed. So this particular model analysis is basically the study of the dynamic properties and frequency domain. So let's say if you're going to deal with the structures in vibrational conditions, we're going to deal with this analysis. So engine vibrations, okay, when you're going to start the engine, it has some vibrations and all, right? So even any of the bridges and all, they might be even having the vibrations. Even if you take the phone, it will also vibrate. If you consider any of the component, it has some own natural frequencies and it will vibrate with respect to the natural frequency limits. Okay, so what exactly it does, so it helps us or allows the design to avoid the resonant frequencies. If in simple, if you want to just consider this, the natural frequency of the tuning fork is 443 hertz, and if you take the same tuning fork one more and if you vibrate one and if you keep it near to that, both will resonate. So even the another tuning fork will also start vibrating with respect to this frequency. So in short, we should not bring the same resonant frequency near to the component which has the resonant frequency same. Okay, natural frequencies of the both the tuning forks are same. If one has the resonance, another will definitely resonate. So this tuning fork has the practical application, that is fine. If it considered for other things, you'll face some catastrophic uh, deformations or failures. Okay, so again it will help us to determine the design to vibrate at a specified frequency. Okay, that also we need to remember. So this particular analysis is mainly relies on the Fourier analysis, that you need to remember, so which will also help us to characterize the mass, frequency and damping ratios. Okay, so this is mainly useful for the engineers who want to deal with the NVH, that is noise, vibration and hardness. So this NVH engineers are highly paid and their role is very important to deal with these all the things. Okay, remember that. Yeah, when it comes to frequency analysis, this is the formula, the total formula. So when it comes to complete things, so we're gonna eliminate the damping and the force here to consider the frequency analysis. The final formula is mass into acceleration, stiffness into displacement. Okay, so this is mass, damping and stiffness, which is equal to force. So what and all we get by using the frequency analysis? The first thing is the mode shapes, very important thing. So by considering the mode shapes, we're gonna consider the natural frequencies. So there is no real displacements, only mode shapes you're gonna get it. Okay, so can we consider symmetry models inside it? No, we should not. Okay, you just need to take the complete model and do the analysis, not the only half section and symmetry. It is not recommended. So what and all the assumptions we're gonna do for this? The first one is the structure is linear, completely linear, and there is no loads are allowed, like the pressure, force and all. It is not allowed here in the model analysis or frequency analysis. The contacts are linear, like bonded or no penetration. These only we consider. Okay, so these are the assumptions we're gonna consider while dealing with this particular model analysis. Examples, if we consider the free oscillation, the pendulum, right? Even we have seen the old age watches and all, which has the pendulums and all, right? And the first oscillation is swing. And even you can consider the tree moving with respect to bend. Okay. Okay, one more is the spectrograph app, which will capture the natural frequency of your voice or the glass sound when you hear it. So the spectrograph is an example again. And when it comes to the distraction, the breakdown of a glass with a sound resonance of 450 hertz. If it reaches 450 hertz, the glass will break. So we have already seen this. So, and then when the catastrophic failure in the history is the Tacoma Bridge broke at 40 miles per hour wind. Okay. Very important thing is why we need to do the frequency analysis. Okay, so very important thing is the products which we design, they should not have the resonant frequencies. To avoid the resonance, we use the frequency analysis. Okay, so which will help us to know about the excitation frequencies of our product, which will be exposed to the environmental conditions. So we can design these components in such a way that the natural frequencies of this particular components do not coincide with the excitation frequencies. Okay, so to bring them into these conditions, we can change the geometry, or we can change the material, or we can even add the dampers and all. Few examples you could see, devices which works with the resonance, which will not fail: the guitar, as I said, the hammers, the pneumatic hammers, the soil compactors, the watch, the mobile, microwave, ovens and all. These will work under resonance, they won't fail. The components which will fail under resonance is the tuning fork, 443 hertz, the fasteners, right, the bearings, the pipings, the blades and the boilers. The blades, if we consider the helicopter blades, we can consider even the boilers. So these all will fail with respect to the resonant frequencies. Okay, yep. So these are the few basic things you need to remember or recall while dealing with the model analysis. That's all about this session. So in upcoming session, I'm going to cover the basics of this model analysis, how to do the model analysis by using different softwares and all. Thank you. Stay tuned. Bye everyone.